Hello everyone, we're going to start today off with looking at these two review problems for the upcoming test over sections 4.1 to 4.3. But pause the video right now. I want you guys to just try number 1. There's a little bit more to number 2 down further. I'll scroll down in a little bit, but pause the video, go ahead and work out number 1 where you want to find each value of C in the open interval from A to B. That satisfies this equation. Here's our function f of x, and then here's the closed interval from A to B. All right, pause the video if you still need more time. Let's take a look at this. Let's work this out on a new sheet here. So if f of x is equal to x cubed minus 2x plus 1, we want to find f prime of x, which would be 3x squared minus 2. Then we just want to turn it into f prime of c, so we could use it in the formula. So that just becomes 3c squared minus 2. So again, just c is a very special x value that's going to complete. We're working with the mean value theorem here, so that's going to just complete the conclusion for it. Then we also want to figure out the slope of the secant line, which is f of b minus f of a over b minus a. So again, we were going from 0 to 3. So we want f of 3 minus f of 0 over 3 minus 0. And we want to set the two equal to each other. So we're going to have 3c squared minus 2. So again, we're just finishing this formula here. So if we do f of 3, 3 cubed is 27. We'll get 27 minus 6, and then plus 1, so that'll give us 22. F of a is 0, so that's just going to give us 1. And 3 minus 0 will give us 3. So it'll give us 21 over 3, which is 7. We're going to add 2. Divide by 3. And then take the square root. So the possible values are going to be plus or minus the square root of 3, but our interval is just from 0 to 3, so c could just equal a positive square root of 3. Okay, I'll scroll down now. You can pause the video. For number 2, this is a lot like 33 and 34 from section 4.3. So pause the video, copy all this down. For part A, I want you to find the absolute extrema and where they occur. Find any points of inflection, and then sketch a possible graph of f. Remember to show enough work to come up with these answers. All right, so pause the video if you still need more time. So two things that we're going to write out here, which is going to help us answer our questions and provide enough proof or work to support our answers, is we're going to make a number line for f prime. We'll do that first. So if we go, and if you look, we're going from -2 to 4, so I want to put that on here, going from -2 to 4, nothing past those. And if you look at f prime, our first derivative is either 0 or undefined right here, so at 0 and 2. So those are our two critical numbers. Then we're going to go over to the sign chart here. So from -2 to 0, our first derivative is positive. Between 0 and 2 is negative, and between 2 and 4 it's negative. So this tells us our function is increasing, decreasing, and then decreasing again. And this also tells us if we're going from increasing to decreasing, where we're going to have a max versus a min maybe, but we'll have to figure this out. We'll make a table of values to help us answer that. But that's enough right now to help us answer part A. But let's go ahead and do the second derivative number line, and then we'll answer everything all together. Notice again how I'm labeling these. And we'll put -2 to 4. So if we look at our second derivative, it's equal to 0 at -2 and at 4. Well, those are the endpoints, but then it's undefined at 2, so we just need this value here. So as we're going in between -2 to 2, if you notice they're both negative here, so that's good because we're only on one interval over here. And then from 2 to 4, it's positive, so that tells us our function f is concave down and then concave up. So let's write out some values here. So at the endpoints, like we can make a table, or we could just say, well, f of -2 is going to be 0. F of 2 is 0. We need f of 0 as well, which that would be 2. And then f of 4 is equal to -1. And sometimes it might even be easier to skip to part C and then answer parts A and B. We could always do that. So we'll go to part C. We'll sketch this graph. And again, I'm going to put the key x values here, -2, 0, 2, and 4. I'll just count up to 2, down to -2. All right, so I'm going to plot those 4 points. So we have a -2, 0, 0, 2, 2, 0, and 4, -1. So we know we're increasing from -2 to 0, and then we're decreasing after it, and we're concave down. So over here, we're going to look like something like this. My page would just stay. We're concave down, we're increasing, then decreasing. And then from 2 to 4, we're concave up, but we're still decreasing. So that's going to look like this. We still have to be decreasing, but concave up. So now to answer part A, out of all these values, the highest point, the highest y value is going to be 2. So we're going to say we have an absolute max, which the graph verifies here, is y equals 2 when x is equal to 0. And our absolute min happens at an endpoint, is y equals -1 when x equals 4. For B, any points of inflection? Well, our function changes concavity at x equals 2, and that was the point 2, 0. And once we do sketch it, we just say that this is y equals f of x. All right, we're going to move on to what's example 3 off of that little sort of half sheet that I gave you guys with the in-class examples. We did 1 and 2 over the last few days, but let's take a look at example 3. This is pretty much all it says. We want to design a 2-liter can that uses the least material. So we're trying to minimize the material that's going to be used and figure out the dimensions of this can that will cause the least amount of material to be used. So there's a couple things, a couple bits of information we need to know here. So the volume of this can is what's the 2 liters. And 1 liter is equal to 1,000 cubic centimeters. We can always draw a picture as best we can of a can here. So since we're given the volume, we need to know the formula for volume of a cylindrical can here. And overall volume is just equal to the area of the base. That's why we always use a capital B times H. And our base is a circle. So our volume is equal, the area of a circle here is going to be pi r squared times our height. So here's our radius, r, and then our height would be right here. but we're trying to use the least amount of material, so that's what's going to go on the can, and that's actually surface area. So when we're trying to use the least material, we're trying to minimize surface area. But they gave us information with the volume. And just going back to this now, since we have 2 liters and 1 liter is equal to 1,000 cubic centimeters, this is actually 2,000 cubic centimeters then. And the formula for surface area of a can or a cylinder, we'll just write this as S is going to equal, so we have 2 circles here, so we need 2 pi r squared because we need to cover the area of the circle, so we'll have 2 pi r squared because we need the top and the bottom. And then if we were to picture like cutting open like a paper towel tube, and we were to lay this flat out, it would turn into a rectangle. So we would still have the height, but what's going to lay flat here is the circle would lay out, and that's actually the circumference, and circumference is 2 pi r. So we would have 2 pi r times the height. So that would be covering the middle part of this can. But our problem here is we have a variable of r and h. We want to get everything in terms of one variable, so that's where the volume is going to help us. We're going to go back to the volume formula here, and we want to solve for h in terms of r. So my volume is 2,000, and that's going to be pi r squared times h. We want to solve this for h. So simply divide 2,000 by pi r squared. So now our surface area, all in terms of r, becomes 2 pi r squared plus 2 pi r, and then h is 2,000 over pi r squared. And we're going to simplify this. This is the function that we're going to take the derivative of and then use it to minimize the surface area here. So as we simplify this, we'll get 2 pi r squared, and here we'll get 2 times 2,000 will give us 4,000, and the pi's divide out, and we have one more r in our denominator. So this is our function that we're going to have to take the derivative of. So off to the side here, we'll just say, well, s prime. And again, pi, even though it's a symbol here, it's still just a number. So we're going to have 4 pi r for the derivative of the first term. And we can think of this as 4,000 times r to the negative first. So we'll get a minus 4,000 r to the negative second, or it becomes 4 pi r minus 4,000 over r squared. So there's our first derivative. So we want to ask ourselves our 2 questions here. Where is this equal to 0? Where is it undefined? So we'll set this equal to 0. And the only way this would be undefined is if r is 0, but r cannot be 0. Because we have to have a radius of some measurement here, so we don't have to worry about that. So going back to figuring out where this is going to equal 0, let's clear denominators. Let's multiply everything by r squared. So we'll get 4 pi r cubed minus 4,000 equals 0. We'll add 4,000 to both sides. Divide by 4. Actually, divide by 4 pi, so we'll get r cubed. It's going to equal 4,000 divided by 4 pi. Simplify this, so we'll just get 1,000 over pi. Now we'll take the cubed root. Cubed root of 1,000 is 10, so we'll just get r equals 10 over cubed root of pi. So that would have to be our radius. If you type this into the calculator, which I'm just going to leave it as the exact form when I go to write anything else out, it's approximately 6.828. And we're dealing with centimeters here. But now we need to either do the second derivative test for extrema. I think I want to do that. Or you could make a number line as well and plug in the values. I'm going to go ahead and use a second derivative test. So I want you guys to pause the video. You go through and do this step on your own and then resume playing to see what you come up with. All right, so our second derivative, so if we're looking at the 4 pi r, it's just going to become a 4 pi. And then we have that minus 4,000 times r to the negative second. So just to go back up to this spot right here. So we just took the derivative of this first term, which would just be 4 pi. If we brought down the negative 2, we would get a positive 8,000 r to the negative third. So this becomes 4 pi plus 8,000 over r cubed. So now if we evaluated this at 10 over cube root of pi, which is a positive number, in here this would also all be positive, so this is all greater than 0. So we would know that we are concave up. Therefore, showing that all of this, we would say there's a relative min at r equals 10 over cube root of pi. And that's our justification. So it wasn't asking us to actually find the surface area, just what are the dimensions that would cause us to have the least amount of material used. So we just need to find the height now. So if you recall, our height was 2,000 over pi r squared. And r is 10 over the cube root of pi squared. We just have to simplify this now. So we're going to get 2,000 over pi times 100. And this will be pi to the 3/2. I'm sorry, 2/3 rather. Index goes on the bottom. And we could think of this as to the 3/3. So now we're going to get 2,000 over 100. And this will just give us pi to the 1/3. So we'll just have the cube root of pi here. And we divide 2,000 by 100, so we'll get 20. So h is going to equal 20 over the cube root of pi. So now we can answer this. So we'll say the minimum surface area occurs when the radius is equal to 10 over the cube root of pi centimeters, and the height is equal to 20 over the cube root of pi centimeters. So we're definitely spending quite a few more days next week over this, even starting on Friday as well, since I pushed the test back to Tuesday. So your assignment then, make sure that you guys look over the solutions video to pages 214 to 217, problems 1, 2, 3, 6, 9, and that, especially that 32A, and let me know if you have any questions over it. Make sure you go back over all of the topics that I listed in class on Monday and go back over previous homework problems, any worksheets that I gave you that give 4.1 as well. So prepare for the test next week. And then 4 more problems from this section, 7, 10, 12, and 31. And then for the AP practice problems on page 29, 76, and 77. Again, you can use the graphing calculator, just no CAS features. As always, guys, just let me know if you have any questions.